Video we're going to be learning about something called the law of sines. Now previously at the beginning of this chapter we learned about sine, cosine, and tangent and how we can use those to find the values of missing sides for a right triangle or a missing angle in a right triangle. But as I mentioned, they only work in right triangles. But in the real world we know that we're not limited to just right triangles. There's obviously all sorts of triangles with angles where triangles that have angles more than or less than 90 degrees. So there's got to be something that we can use in trigonometry to be able to help us out. Well, one of those rules or laws is called the law of sines. And that's what we're going to be looking at today. But before we do that, there's a phrase that you need to be familiar with, and that's solving a triangle. If you're ever asked in your assignment to solve a triangle, what it's asking you to do is it's asking you to give the measure of each of the sides and find the measure of each of the angles. So when you're finished, you should have a total of 3 angles that are known and 3 sides that are known. So one of the tools that we need to know about is called the supplements theorem. The supplements theorem, what that tells you is that's going to give you all the angles in degrees where it says for all angles in degrees, the sine of an angle is going to be equivalent to the sine of 180 minus the angle. So in other words, if we want to find another angle that has the same sine value, you subtract it from 180. Let's look at this example. Here they say find all solutions. Now the key there is we're trying to find all the solutions, not just the measure of this angle, but we're trying to find all the angles where the sine of that angle would be 0.842, and the angles that we're looking for is between 0 and 180. So first off, on your calculator, what you're going to do is to find the measure of an angle, we're going to use the inverse sine. Oops. Of 0.842. When I do that on my calculator, the inverse sine of 0.842 is going to be 57.4. degrees. Well, that's just what the calculator tells you. There's going to be another angle that would be that if I take the sine of that angle, it too would give you 0.842. Because if you think about it, in quadrants 1 and 2, we're reflecting these angles over the y-axis. So there's going to be another angle over in quadrant 2. So we know that 57.4 degrees, which let's say is right here. So the sine of 57.4 degrees is 0.842. There's another angle over here in quadrant 2 that's going to have the same sine value. So to figure out what that would be, we're going to take 180, we're going to use the supplements theorem. I'm going to take 180 minus 57.4, and when I do that, I get 122.6. So the other angle is 122.6 degrees. So there's 2 angles between 0 and 180 degrees, where if I take the sine of them, I get 0.842. Because if you do that on your calculator, whoops, if I take the sine, that's just because here's how you can check your answer. If I take the sine of 57.4, I should get 0.842. Sure enough, I did. Now if I take the sine value of our second angle that we found, 122.6, I should also get 0.842. And sure enough, we do. So you can see that these two answers are angles where the sine of these angles give you a value of 0.842. So to find that angle, we always take and subtract the known angle from 180. So for the next one, I would use the inverse sine of 0.528. So that's going to give me one of my angles. That gives me 31.9 as my answer. Once it's rounded 32 degrees. To find the measure of the other angle, I'm going to take 180 minus 32. Well, 180 minus 32 is 148. So the other angle is going to be 148 degrees. You can check your answer because if you take the sine of 32, you should get 0.52 or 0.528 rather, or 0.53. Same thing if you take the sine of 148, you get the same answer. So that's how we use the supplements theorem. But here's the key for this lesson. This is called the law of sines. And you want to make sure that you also draw out this triangle in your notes if you're doing these notes on your own. Now we use the law of sines when we know the angle, and side of a triangle, or angle, side, angle. So the included side between two angles. And what the law of sines tells you is we can set up a proportion here. Now notice some things about this triangle. We always use capital letters to represent a vertex. We use lowercase letters to represent a side. And the sides are always going to be across from, the corresponding sides are going to be across from the angle. So if I say side A, that's going to be across from angle A. If we talk about side C, that's going to be across from angle C. And same thing with B, is going to be across from angle B. That's important to make sure we know. And also, again, it's going to be a proportion here, where it's always a sine of an angle over the side across from it, is proportional to the sine of another angle over the side across from it. So write that down in your notes. And so you might have to pause the video so you can get all that down, but let's look at this example. Here it says 2 forest rangers are in their stations S and T 30 miles apart from each other. On a certain day, the ranger at S sees a fire at F, an angle of 38 degrees. Okay, so here's station S, here's station T. It's saying that we have a 38-degree angle formed beside ST, so that's your 38-degree angle. The ranger at T sees the same fire at 64 degrees from side ST. Find the distance from the station T to the fire. So we're trying to figure out this. I'm going to call this X instead of S. It's too easy to look at S and think that's 5. So I'm going to set this up, again, using proportions. So here's the way we do this. I always like to look at what side are we trying to find. We're looking at, or what are we trying to find? In this case, we're trying to find side FT, which I'm calling X. That's across from this angle, so it's going to be the sine of 38 over the side across from it, which is X. That's what we're trying to find here. Now, even though I know that angle T is 64 degrees, I don't know anything about the side across from it, and I can't do anything to find that side, so I'm not going to use 64 degrees. I'm going to use this side here, that's 30 miles, and the side across from it, which is angle F. But the problem is I don't know angle F. But I do know there's 180 degrees in a triangle. So in order to find the measure of angle F, I'm going to take 180 minus 38 minus 64. And when I do that, I get my measure of my angle, which is going to be a total of 78 degrees. So this angle here is 78 degrees. So it's going to be the sine of 78 over the side across from it, which is the 30 miles. And now in order to find out what X is here, we're going to solve this proportion. To solve a proportion, we multiply the two values that are diagonally across from each other and divide by what's left over. So we're going to take 30 times the sine of 38. Now it's important to do it in this order. 30 times the sine of 38 and not sine of 38 times 30, because otherwise people often make mistakes forgetting to close off the parentheses. We're still going to have to close off the parentheses. I'll show you what I mean by that here in a second. But we're going to end up dividing by what's left over here, the sine of 78. So if we go to our calculator here, we're going to type it in like this. It's going to be we're going to take 30 times the sine of 38. Now you want to close off the parentheses and then divide by the sine of 78. And when you hit enter, it should look exactly like what we put in our notes, and that's what we have. So your answer here is 18.9. So your answer is going to be 18.9 miles. If they say it around to the nearest mile, obviously you'd say 19 miles. That would be your answer. So station T is 18.9 or 19 miles from the fire. Now you're not always going to be given a diagram, so you need to make sure you know how to draw out the diagram if you need to. So here it says stations S and T are 18 miles apart. And the ranger at S sees a fire at an angle of 42 degrees. So we call this angle, say that's 42 degrees. And the ranger at T sees a fire at an angle of 74 degrees with TS. Find the distance from station T to the fire. Station T to the fire would be this side here. So again, we're going to use the law of sines. So I know I'm trying to find this side, so that's across from the angle, that's 42 degrees. So it's going to be the sine of 42 over X equals, and I'm trying to use all my proper information here. So this side here, that's 18 miles, is across from angle F. Again, I don't know angle F, so I have to find that out by taking 180 minus 74 minus 42. When I do that, I get 64 degrees. So it's going to be the sine of 64 over 18. Remember, we multiply by the two numbers that are diagonally across from each other. So to find x, you're going to take 18 times the sine of 42, and you divide the whole thing by what's left over, the sine of 64. And when you do that on your calculators, I'll just tell you, you get about 13.4 miles. Okay, so once you get the hang of it, these problems are rather simple. So let's look at the next one. Here you have triangle ALG, that's where angle A is 55 degrees, angle G is 17 degrees, and side A is 7. So this is a situation where we have an angle, and a side. So we can use the law of sines here. So it's going to be I'm looking for side G. I'm trying to figure out this side here. That's across from the angle that's 17 degrees. So it's going to be the sine of 17 over G. I know this side here, that's 7. Well, that's across from angle A. This time I know that angle, so I don't have to do any math. I'm just going to take the sine of 55 divided by 7. So to find out what G is, we're going to take 7 times the sine of 17, all of that divided by the sine of 55. And I'll just tell you again now, when you do this on your calculator, that you're going to get about 2.5 as your answer. So G is 2.5. So I want you guys to try this last example on your own. Why don't you guys, you're going to have to draw out the triangle on your own as well. So why don't you pause the video and hit play when you're ready to check your answer. Okay, so let's see what you did, or maybe you're waiting to see how to set this up. So what we would do is we would draw a triangle. Again, when you draw a triangle, it's just going to be used as a reference, so it doesn't matter if it's exact here. So I draw my triangle. Call this T, R, and I, where angle R is 25 degrees. Angle I is going to be 72 degrees. Obviously, that's not right as far as my shape is concerned here, but again, I'm just using it as a reference. And side R is 13, so that's going to be across from angle R. And we're trying to figure out what T is. We're trying to find this side over here. So to do that, again, I'm trying to find this side that's across from this angle. So to figure out what angle T is, we're going to have to subtract what we know from 180. So it's going to be 180 minus 25 minus 72. Whoops. So 180 minus 25 minus 72. When you do that, you get 83 as your answer. So it's going to be the sine of 83 over side T, which we're trying to find, equals, and I have 13 and 25 across from each other, so it's going to be the sine of 25 over 13. Multiply by what's diagonally across from each other, so to find T, we're going to take 13 times the sine of 83, divide the whole thing by the sine of 25, and when you did that, you should have gotten 30.5 as your answer. So that's the value of T. Okay, so with that, that's all we're covering in our notes today. So that's the law of sines. So hopefully you understood that. It's a relatively easy concept. The other thing you want to remember that we talked about at the very beginning is this idea of the supplements theorem. Is you just find the measure of another angle that has the same value for a sine. You take 180 minus the measure of the angle. So with that, good luck on your assignment.